I'm pleased to invite Abdullah Mueen, one of our rock star computer scientists, who has awards with things like the Test of Time Award in a machine learning conference, a recent research award from UNM, and he has all kinds of intriguing things like intelligence, anonymity, and blockchain in his title. So, Mueen.
Thank you, Melanie. I think I do better without this. So can you hear me in the back? Okay, good. So let's talk about money. So we'll talk about the blockchain, and it's very relevant now. It's getting all-time high price and so on. So we'll start with very specific, the Bitcoin blockchain, right? So that's the kind of the oldest one, and we'd like to understand the blockchain and how people act on that blockchain. So Bitcoin is so I have 3 slides that will just give you a very rough introduction to Bitcoin, the blockchain, and then we'll talk about what we do. So it's a peer-to-peer electronic cash system, and you don't have to read it. The main thing is that in the Bitcoin blockchain, you can send money, right? You can give money to somebody, and that transaction happens through cryptographic guarantees, right? So you have the first owner encoding or encrypting the money or whatever it is, the data, with its private key, and with the private key of the next one, and then send it to the next one, and it keeps going on and on and on. So anybody who has the latest coin can be able to encrypt or decrypt that particular coin based on the private key of that person. So in a sense that it's a way of chaining your transactions from one person to another, and so on. And those transactions are also grouped, meaning that in a block you have many transactions, transfers of money between one person to another, or many persons to many persons. And in general, for example, this is an example. You have in this number of block 817832, you have 3,000 transactions in it. And each transaction has a set of input users and a set of output users, or senders and receivers. And generally, every 10 minutes, we get a new block. So about 1 megabyte is the size of a block that's getting added to the blockchain. And this whole information is public. So we can see what has been happening on the Bitcoin blockchain since, let's say, 2007. So this whole data set is public, and we have analyzed that to find some interesting facts. So now, up to that, so that my introduction is over about Bitcoin blockchain. So now let's make analogy to the banking system. Right, in a banking system, when you send money, right, so one person, or maybe if you have a joint account with somebody else, then multiple people send money to multiple people. So Bitcoin has the same kind of thing, multi-input, multi-output situation. So in where, if you send money together with multiple other people, let's say 3 people are sending money to this particular address, then they have to sign in with their private key, meaning that they have to trust each other. Otherwise, which is what happens when you create joint account in a bank, right? So you don't create with another stranger a bank account, right? So you create with somebody you trust, and maybe in your family and so on. So, and this grouping that 3 people, 5 people, 10 people, 100 people are spending money together in one single transaction, that clusters them together based on a trust relationship. And we can explore that trust relationship further based on time, and that's what we're going to do. So here's an example of a multi-input, multi-output transaction. So 3 people, of course you do not see their name because it's an anonymous network. You see only their hash key or address. So it's a very big long string of letters and numbers. It means nothing to us, but it is only decryptable by the person who created it. So you have 3 people sending money of different amounts to 2 different people. So the sum of the output money equals the sum of the input money. Very simple. So that's how a multi-input, multi-output transaction happens on a Bitcoin blockchain. So if you know that, you can actually create interesting statistics or information about the Bitcoin blockchain. For example, let's say here each cloud is a transaction. So in the left you have 3 people. It's a cartoon, of course. 3 people are sending money to 2 people, 2 orange people. Here, 1 person is sending money to 2 orange people, and so on. And those people are sending money again, and it goes on and on and on in the chain. But the fact that this person spent money together with these 2 and those 2, that connects them all in a trusted relationship, right? So if I have a joint account with my wife, and my wife has a joint account with my son, then it connects my son and me to be trusted to each other. And that's how you can create in the blockchain, Bitcoin blockchain, a set of clusters of addresses. They are all connected based on trust relationship. And what you're seeing here, this is not cartoon anymore. In the x-axis, you see the dates. It's oddly day, month, year format. And in the y-axis, you see the number of transactions received by a particular cluster. It's an example cluster. The cluster of people. In this case, you can just make an analogy that this is the set of orange nodes that received money in that form. And what you see, surprisingly, that in 2015, it went to 0. And then ignore that spike for now, just for now. It went to 0 and it never had any money received. So what happened to that account or that set of accounts? There is money there in that account and it's not receiving anymore and nothing is happening to that. Then we see that another one, let's say another transaction, another cluster, let's say YOLO, that's like this, that it didn't have any transaction, any money receiving before 2015 and any after 2016, let's say. Within that period of time, it had very nice money receiving patterns. We can see more. And the more important thing is when we put them together, all these 3 things, we see that actually these are same service, same high-level organization. In this case, this is called bitpay.com. And that bitpay.com had an initial set of accounts where they received money, then they abandoned it. Meaning that they regenerated their hash addresses and abandoned the old one. And then they started receiving money in the new ones, receiving, and at that point, they again abandoned. And we don't have the knowledge in the current Bitcoin blockchain annotation, the ones that produce this, what are the accounts that receive money in this region. And then we have some more information, again some gap, more information gap, and so on. So what is happening is these services, let's say bitpay.com, you can analogously think about gambling websites, or maybe websites that sell things that are not so legal, right? So they take money from people in these address clusters or in these addresses, and then they change their nature, the IDs. And our goal is to be able to fill in those gaps. Not only that, to be able to project in future too. Meaning that we have until 16. What happened after that? Right? In the last 8 years, we don't know whether BitPay is continuously receiving more money or not. And that is the question we ask. And the interesting thing is, what you see or what you notice here is that this orange signal, it drops here while the yellow one starts. Again, here we do not see that, but we can formulate that. Oh my goodness, where is that slide? We can find those clusters from the Bitcoin blockchain by using our machine learning algorithms. Go ahead, please.
Why are you asking that question? Like, are you trying to detect fraud?
I'm trying to complete their crime history so I can tell how much tax they owe.
So you're kind of the IRS.
I am the IRS, yes. Because they have received money which they can easily hide, right? So I could complete that access. Yes. So the way we do it, it's very interesting, small little thought experiment that we can do. Let's say I give you a set of chain segments. Let's say you have a bowl, and you have a lot of such small chain segments, and I give you a comparator. Like I give you the ability to see a pair of chain segments and answer the question, can I join them? And you have the tools to join them too. So if I give you that ability and get that bowl of chain segments, with enough time, you can actually connect, and create a unique set of chains. There will be no segment, no two segments, no two chains that are not different, and you will be creating the whole set. Now, this task is very simple. Like maybe my 8-year-old daughter will be able to do it, right? Because they will look at the link, maybe if that can be connected, and so on. But the same thing, we are asking the model to learn. Our model is using transformer-based models, and it has all the convolutional systems and so on. I will not go into detail of that. But the gist of this thing is that this particular task is an intelligent task. It's not something that somebody with very rudimentary level, like 4 or 5 year old probably wouldn't be able to do. But we are not doing on chains. We are doing it going back. We are doing it on time series. So this one and that one links because they come up and down at the same time. Their patterns in the left and right are the same. Their dynamics are the same. The whole thing has to come from the same service called bitpay.com. So we take the blockchain, create the time series for all the address clusters, train a neural model which develops that comparator. And if you have, and that comparator does not look at chains, it looks at the time series, and that comparator, when successful, can give us the one that comes next. And that is what we have done. So example of such chains, links, you can see here there are different systems: Bitfinex, local bitcoins, Vitor, Cryptsy, Antpool, Crime Network. Here you see the years, and if I zoom in this region, then that's what you see here in the bottom. So zoom in here, that's what you see in the bottom. And you can see the red goes down and the blue goes up. So that's the thing, that one group of addresses are being abandoned or moved to some place hidden, and another one is being populated. So these are examples that we have found, and we can actually learn from this, that comparator that I mentioned. And once we learn that, we can use it to almost fill any gaps in the transaction histories. So let's see one example. So here is a service called Helix Mixer, and it's a banned service. So federal regulatory authorities, they banned it. And they banned it in 2018. So all these small segments are different address groups that received money in the name of that service. Whether the people got their money back or not, we don't know that yet. So, but these are different clusters, and you see that one goes down, one goes up, and there are some missing pieces too. And we have actually found the missing pieces. We moved forward, and we moved backward too, to complete the entire transaction history for this particular service. This is the time when the service was banned. And the way we verify that, how do we know? Like, you can ask the question that, how do I know that I found the transactions of that particular service? The answer is that in this particular case, what happened is one guy in Reddit was complaining that, hey, I sent money to Helix Mixer and I didn't get it back. So, and he posted the address in the Reddit post. So I could trace back from that and see, oh, yeah, that is what is happening. So, but of course, if I had money myself that I could spend on Bitcoin blockchain, then probably I could verify myself too. Like asking Helix Mixer, hey, I want to use your service. Where do I send money? and they would gladly give me the address. So bottom line, as IRS, what do? I predict that, for example, a service like Helix Mixer, the known ground truth was $57 million that they have earned. We extended that on top of that about $59 million, meaning that they actually, it's not possible for IRS to know that these $59 million were also received by Helix Mixer without the tool that we have developed. Now, last slide. So generally, anonymity and privacy, these are, so anonymity means that I can be anybody, and I would love to be mixed in the crowd and not being identifiable, while privacy means that I want to be only myself, not anybody else. So, and Bitcoin is anonymous but not private, because it's public. We can go and download the whole blockchain. So other examples also, like airport, bank, or voting system, they have different kinds of properties. But the bottom line is, if you want to have privacy or anonymity, the cost is increasing. Think about it that when, like 10 years back, you didn't have two-factor authentication, right? So you didn't need to have a device. Now you need to have a device to be able to log into your system, right? So the cost of that authentication system is increasing. Similarly, whether you think about other kinds of anonymity or privacy, it's increasing in the way that the people who are trying to damage privacy, they are also using the AI. They're also using the AI. So both groups are using AI, one to protect the privacy, the other is to damage the privacy. They're both using AI, and at the end, it becomes a resource race. So whoever is using more resource, energy, power, money to train the most complex system to protect the privacy versus the ones that are destroying it. And at the end, I think it will continue. It will continue as long as we want anonymity and privacy. If we say that we don't care, then maybe it's solved, but I don't know if that's going to happen in anytime soon. So that will be just my last bit. So this work was done in my lab with Sheng Zong. He graduated last year, now works for a local company, and we did make a company out of it. Thank you.
Great, so I'm sure we have lots of questions for Mueen and John. Come on up and we'll swap in your lab.
Yeah, I hope I tried to explain it without the details, but let's see. Go ahead, please.
Yeah, I'm a little confused. Is the goal to make things more secure or less secure?
The goal is to understand for this issue, of course.
So now, comfortable middle ground.
Yes, that is. But of course, I mean, if you ask the future plan around this particular work, I think it would be to make it more accountable in terms of the money people are receiving through blockchain. Yes?
Once the nefarious world gets hold of this tool or ability to understand this, do you foresee that they're going to be able to do workarounds?
That's a very good question. In the fact, there are two components, right? So the historical analysis, they will not be able to do anything because it's already in the blockchain, it's already there. So they cannot hide their trace that we are analyzing now. Now in future, they can do one thing, which is the ultimate cost of this blockchain, is that if you change your ID after every transaction, imagine that you are going to the bank, you withdraw money and you change your account number. And then again you do another transaction, you buy something with your credit card, you change your account number. If you keep doing that, then only ultimately you guarantee your privacy. But that is going to be costly. So that's where the resource race will be. And the person who wants the ultimate privacy will essentially change its identity every time the transaction is happening. And at that point, I think my tool will fail. Yes? Okay, go ahead, Chris.
So, a lot of the value of blockchain really is this anonymity.
Yes.
Privacy. Would this basically either require, won't this destroy the value of Bitcoin, right? If you, so look, I can, with all my analysis, figure out the whole network of interactions. Once I know a few things that used to be private, I can connect dots. And now you have the potential for sort of a big brother intervention that can expose everything that everybody did. And then we'll say, well, through this, we'll move to another model of Bitcoin that doesn't have this vulnerability, and you destroy the whole $1 trillion plus value of this instrument.
That's a hard question. So, so if you remember, like intelligent data analysis with AI tools can reduce anonymity, as you understand that, because I mean, if we can predict people's behavior, then we can connect dots, as you just mentioned, and we will be reducing anonymity, no doubt. Now, the core guarantee that Bitcoin blockchain provides, that if you do change your hash key after every transaction, it's, I mean, the only way it can be broken if you have the quantum computers which can break the encryption, right? So that's the only way it will happen. So, but I think this is not going to destroy the whole technology. It will just make people be more cautious, and whoever wants to maintain privacy must be spending money for that. That's probably what we are going to do. I mean, I don't think it is going to destroy the whole technology. Yeah.
We probably should cut questions here. Sorry about that. It's fascinating thing. So make sure you track Mueen down. Ask him whether you should invest now or later in Bitcoin. And let's give a round of applause.
Thank you.